Okay, now we're going to look at graphing quadratics in factored form. So you have graphed quadratics in standard form. Now, this is just another strategy. If you're given an equation in factored form, this gives you a process for graphing the equation. Okay, so our factored form would be something like this. A times the quantity x minus p times the quantity x minus q. And so this would be a factored format where we have, two binomials, um, a GCF that's been factored out. So, like I said today, this process is going to be something that you can do if you are given an equation in this format and you want to graph it without having to, simplify and turn it into standard form or anything like that. Okay, so the first important piece of information is a definition, zero product property. So the zero product property says if A times B equals 0, then A or B must be 0. Okay, so if you have two numbers multiplied and together they equal 0, one of those two numbers has to be 0. Okay, that's going to come in handy as we go through our steps for graphing. So step 1 is going to be find the x-intercepts. And we're going to be using the zero product property when we do step 1. Step 2, find the axis of symmetry. Step 3, find the vertex. Step 4, find at least 2 more points. Okay, remember, we want a total of 5 points. We'll get you a good parabola, right? All right, so we're just going to jump straight into an example. And we're going to use these 4 steps. So we want to graph y equals x minus 2 and x plus 4. Okay, so step 1, find the x-intercepts. So if we remember, x-intercepts, or an x-intercept is where the graph crosses the x-axis, right? So it's where we cross the x-axis here. So we know whenever we cross the x-axis, the y is 0, right? So we're going to get 2 ordered pairs, hopefully, where the y coordinate is 0. Now, this zero product property comes in handy because it says if you have 2 numbers multiplied and they have to equal 0, then one of these 2 must be 0. So what we have here is if my y is 0, so if I substitute my y with a 0, then what I'm saying is if these 2 expressions multiplied equaled 0, then that means x minus 2 has to equal 0 or x plus 4 has to equal 0. One of those 2 expressions has to equal 0 to make y 0. Okay, so what we do is we go through and we're going to set each of these equal to 0 because what I want to say is, okay, well, if this term was 0, what would the x have to be? Or if this was 0, what would that x have to be? So this is going to kind of get us our x-intercepts. So first here, the x has to equal positive 2, and here the x has to equal negative 4. So that gives me my two x-intercepts. Okay, so if x was 2, y would be 0. If x is negative 4, y would be 0. So now let's go to the graph, plot our 2 points. Okay, and step 2 is to find the axis of symmetry. Now the thing is, in the previous lessons, to find the axis of symmetry, we used a little formula, negative b over 2a. The only thing is, this equation is not written in standard form. That's only for standard form. Now, I could simplify this and get it into standard form and then do negative b over 2a, but that's extra work that's not actually necessary. We know that the axis of symmetry cuts the parabola in half. It makes like a mirror reflection. So if I look at my two x-intercepts, and I remind myself that we have a reflection, I know that if I were to draw a line between those 2 points, that's actually my axis of symmetry, right? My one x-intercept is 3 to the left, the other is 3 to the right, so I know that's the middle. Now, if you don't have this graphed first, that's okay. What we can do is find the middle of the x-intercepts. That's all we have to do. Okay, so in this case, my x-intercepts were 2 and negative 4. So it's kind of like finding the median or the average. Negative 2 over 2 is negative 1, so the axis of symmetry would be x equals negative 1. And if you graph it, if you graph your x-intercepts, you'd be able to find it visually. Okay, step 3, find the vertex. So we know the vertex is going to be a point where the axis of symmetry is my x-coordinate, and then we just need to find the y. So I take my equation, my function, and I replace the x with a negative 1. And I get y equals negative 9. So now I have the point negative 1, negative 9. And you'll notice that the vertex is on my axis of symmetry, which is good. The last step 4 is to find 2 more points. So we definitely want at least 2 more so that we can have a better visual of what this graph is supposed to look like. So I can pick any 2 x's that I want. I'm going to pick 0 here because I think it'll just make the math a little bit faster. So if I pick x equals 0, then I'm going to go through and I'm just going to substitute and do the math. So when x is 0, y is negative 8. Now the thing is, I don't really have to go through any math to know that if I went to the right one and I get my point at negative 8, if I go to the left, that's my other point because it's that mirror image, right? So I also know that if x was negative 2, my y would be -8, right? So technically, I really only had to find one point, and then I automatically could get the other. And then we just connect our points, and that's it. Let's do example 2. Now this one is going to be written as a function with function notation, h of x. It's the same thing as y equals. Sometimes you will be given the equation in standard form, and either you'll be told graph it using factored form, or maybe you prefer graphing with factored form and you want to factor this. But I did just want to show you an example where you're given standard form, and then we can rewrite this in factored form. I need my two numbers to multiply to make 12, add to make -8. So it's -6, -2. Just gives you a little factoring practice. And then we're just going to go through our steps. So step 1 is to find my x-intercepts, right? So then I know my y's will be 0. So I'm just going to substitute my x's with, or excuse me, my y with a 0 and figure out what the x is. Now this would be a lot harder to do with this in standard form. So that's when factoring comes in really handy. So I know that x minus 6 has to be 0, or x minus 2 has to be 0. X has to equal 6 and 2. So let's go ahead and graph those. Okay, there are my two x-intercepts. Step 2, axis of symmetry. We want to find the middle between my two x values for my intercepts. Add them, divide by 2, gets me the number that's in the middle of 6 and 2, which you may not have even had to do that math. You might have just been able to figure out that it's 4. Mental math, or by looking over here and seeing that in between my two x coordinates, or between my two x-intercepts, gives me my line of symmetry. Now you can do this with any 2 points. It just so happens that the x-intercepts are the easiest to find first. So anytime you have 2 points along the same horizontal line with our parabolas, we know that the middle is the axis of symmetry. Okay, part 3, vertex. So for the vertex, we know that it's this, my x-coordinate is the axis of symmetry, because remember, it's going to be the point where that mirror is at, right? Then I substitute. I'm going to replace the x with a 4. Make sure that you're being very careful with your positives and negatives. Y is -4. And then step 4 is to pick at least 2 more points. So now I could pick a point, x is 1, x is 0. I could pick x is 3, so I could see what's next here. Totally up to you what you want to pick. I'm going to go with x equals 1. But again, you can pick whatever ones you'd like. So if x is 1, then y is 5. So if x is 1, y is 5. So then I know if this is 3 away from the axis of symmetry, I know that my other point is 3 in the other direction. And there's my parabola. Example 3. Okay, so this, we're going to toss a couple things you haven't seen yet here. All right, so this is in factored form. We do have a negative out front now. We didn't have any numbers before, but now we've got a -1. You've been seeing two binomials, right? And we don't have that here on first glance, but we actually do, because anytime I have something squared, that means it's multiplied by itself. So what I'm really dealing with here is x minus 3 times x minus 3. The negative is not squared because it's not in the parentheses. It's on the outside. The base is x minus 3. Okay? All right, so step 1, x-intercepts. So I'm not going to write my ordered pairs quite yet, but I do know that y has to equal 0. And if I look at this, I have the same binomial here. So technically, the only part that has to be made equal to 0 is x minus 3. I can't make this this is really a -1, right? I can't really make that -1 into a 0. There's no variable there to be able to manipulate. So what I find is that if x equals 3, then y has to equal 0. So that only gives me one x-intercept. Whenever you have one x-intercept, that actually means that it's the vertex. So what you can have happen, let me bring in an extra little graph paper here, is you won't always have two x-intercepts. There's a chance that your parabola could go like this, right? If my parabola is here, it's not crossing the x-axis at all, or something up here, right? That can happen. So if you don't get any x-intercepts, you know that your parabola is not going to pass through the x-axis. But you also could have a time where your parabola touches the x-axis and keeps moving on at the vertex. And that's what happens here when we get one x-intercept. That means that the vertex is actually on the x-axis. So when it gets to number 2, where we need to know our axis of symmetry and 3 our vertex, it's actually pretty easy knowing that that x-intercept is the vertex. So my axis of symmetry is going to be at x equals 3 because, because this is my vertex, or my vertex is going to be right here. So for the vertex, we have 3, 0. So that means when we do number 4, get extra points, I need more than 2. I actually need 4 points, right? Now I do know that, if I get 1 point, I can do the mirror image and get the other. So it's really not that bad. So I can move 1 to the left or the right of my vertex. You could also pick an x, like I could pick x equals 0 to see what happens, just because I think like mathematically that might be a little bit faster. So let's try that. So if x is 0, make that red. I do the math, just replace the x with a 0. We get +9. Oh, no, we don't. Sorry. We get negative 9. So when x is 0, y is negative 9. Now, because this is my axis of symmetry, then I know I have another point right over here. And then maybe we want to try x is 1 or x is 2. Let's try x equals 2. I'm not going to do too much in my head because obviously doing too much in my head was not the greatest choice. So when x is 2, y is negative 1. And there is my parabola. A couple things to notice. In front here, I had a negative 1. My parabola points down. Okay, that's the A. At the beginning of our notes, see, we had the A out here, right? So that's something to think about. Up on example 2, my A would have been a 1, opens up. Okay, so there are still some similarities from what we did in the last lessons as well. All right, so let's do one more example. Y equals negative 2 times the quantity x plus 4 times the quantity x plus 6. So if negative 2 is my A, I can think, okay, it's going to open down, right? That's something to kind of think about. Any little patterns you can see that you can use to mentally kind of prepare yourself for what's going to happen is always good. So my x-intercepts, I'm going to make y equals 0. Now there's nothing I can do with the negative 2, so I want to make either this binomial 0 or this binomial 0. But we need to be prepared for either case when we write our x-intercepts, right? So x can either be equal to negative 4 or equal to negative 6. Let's go to negative 4 and negative 6. Now for the axis of symmetry, I know it's going to be x equals, and I know it's going to be this, my water cap. It's going to be this right here, right? In between those two numbers, in between negative 4 and negative 6 is negative 5. If you want to do the math, it would be negative 4 plus negative 6 over 2. Negative 10 over 2 is negative 5. Number 3, the vertex. I know the vertex is going to be somewhere along the axis of symmetry line, right? So I know that my x-coordinate will be negative 5. I just have to figure out the y. So I'm going to substitute negative 5 in for the x's up there. So we get y equals 2. So negative 5 and 2. Then our last step is to pick more points so that we can have at least 5 total, right? I'm not going to stray too far away from my axis of symmetry just because I don't want to run out of space. So let's just go with x is negative 3. Okay, so we just work all that out. And we get -6. So when x is -3, y is -6. And also, make sure you're checking your arithmetic and your calculations. If I got +6 because I did something wrong with the positives or negatives, if I notice myself coming up here, I know that's going to be wrong. Okay, so as you're plotting your points, make sure that you're giving yourself a second to decide, does this make sense, right? So then I know my other points 2 to the left. And that gives me my not so pretty parabola there. And that's it.